So 15th one, we completed till 15th last time. So here the principal functional group is aldehyde, it is CHO, and hence I start numbering from the carbon of CHO. That is 1. 1, 2, 3. So the side chain is the main chain for me here because the side chain contains the principal functional group. And hence benzene ring will be treated as a substituent. So the name will be 3-phenyl because at the third position I have this entire thing as a substituent. So 3-phenyl, prop because there are 3 carbon atoms in the main chain, prop 2 in, En, double bond position is indicated, that is this one. At the second carbon you have a double bond. So prop 2 enal. 16th one. So here the principal functional group is OH. OH is attached to the benzene ring directly. That is why this carbon will be 1. I do the numbering in the clockwise direction. If I do the numbering in clockwise direction, the positions of substituents will be 2 and 5. At the second position, I have F. At the fifth position, I have Br. So the name will be 5-bromo-2-fluoro-phenol. 5-phenol, because if OH is directly attached to the benzene group, that part is called phenol. The suffix is phenol here because that is the principal functional group. Whatever is the principal functional group, accordingly the suffix will be used. If I go in the anti-clockwise direction, that is, this is 2, this is 3, this is 4 and 5 and so on, then the positions of substituents will be 3 and 6 respectively. That is why I don't go in this way and I choose this, because I need the lower set of logams. Hence the name is 5-bromo-2-fluorophenol. Biphenol. Okay, so the principal functional group is OH here because bromine and fluorine don't have any priority in the priority series, right? Bromine and fluorine always are treated as substituents. Now, OH is directly attached to the benzene ring, and that is why the carbon containing the OH will be numbered 1. The moment I say that the carbon containing OH has been numbered 1, I'll have to use the suffix accordingly. The suffix for OH attached to benzene is phenol. If you look at the table that was taught to you last time, this table has to be learned by you, right? This table. So this table contains the names of the IUPAC names of certain aromatic compounds, which are very commonly used, the ones which we will be needing on a regular basis. So if you look at the second one, you see phenol. So phenol is the IUPAC name of this compound. Hence the suffix has been used for that. These all are suffixes. Whatever IUPAC names I have written in the table, all will be suffixes. They are never prefixes. These all are suffixes. All, right from 1 till the end. All these will be suffixes. Okay. Next one, 17th one. Again, COCl is acid chloride, and that is the principal functional group. That is why this carbon has been numbered 1. The positions of substituents will be 3, 4. 3 at the third carbon I have bromine, and the fourth carbon I have chlorine. So this will be the name. 3 bromo, 4 chloro, and the suffix will be benzoyl chloride. Why benzoyl chloride? Because when COCl is attached to the benzene ring, it is called benzoyl chloride. I have taken it from the table which I showed you just some time back. Refer to the table whenever you have a doubt for suffixes of aromatic compounds. Eighteenth one. So again, if you see OH is the principal functional group. So OH is again directly attached to the benzene ring. So the carbon containing OH will be numbered 1, and all the other things which are attached to the benzene ring will be treated as substituents. So this will be the name of the compound. There are 3 NO2 groups attached. So trinitro. Tri stands for 3. So trinitrophenol. Suffix is phenol. Nitro is the prefix for NO2 because NO2 is a substituent. 2, 4, 6 are the positions of the carbon atoms which contain the NO2 groups. Tri means 3, since there are 3 nitro groups attached. If you number in the clockwise direction, then also you will get 2, 4, 6. If you number in the anti-clockwise direction, then also you will get 2, 4, and 6 as the positions of substituents. Which list? There is the priority series is only and only for the functional groups, not for anything else. The same priority series is applicable here also. The priority series that we had learned earlier, that is COH carboxylic acid gets the highest priority, followed by others. That is the same priority series which we are using here as well. Priority series is very important, irrespective of whether it is aromatic or not, because everywhere we are using the same concept. Whichever part contains the priority will definitely be treated as the main chain or the main component or the parent structure. So the priority series has to be learned by you. Carboxylic acid, sulfonic acids, esters, and so on. So all those which I had given earlier. NO2 is always a substituent. Fluorine, chlorine, bromine, iodine always are substituents. OCH3, that is methoxy, is always a substituent. Okay. Next one. 19th one. Now, in the 19th one, you don't have any priority functional group. You don't have anything. So, in that case, the benzene will become the main or the parent structure. And whatever is attached to benzene will become the substituent. So, cyclohexyl is the substituent attached to the benzene. 20th one. So again, if you see the benzene has a side chain, the side chain is CH double bond CH2. So this will be 1, the carbon containing the side chain, and so on. So this is the numbering. Benzene is the parent structure here. Benzene is the parent structure here because there is no functional group attached to the side chain. The side chain just has a double bond. It does not have any other functional group or anything which is priority. That is take this as the parent structure. Some people take this as the parent. No, this is not the parent. Benzene will be taken as the parent. All these three are IUPAC names. Remember compound. All these three names are IUPAC names. STYRENE, styrene. Styrene, also called ethynyl benzene or vinyl benzene. I told you last time this group is called ethynyl when this is a substituent. This is called ethynyl. You call it ethynyl or you call it vinyl. This group is called ethynyl or vinyl. Okay. Now, important point, like we did in cyclic compounds, that is, if two or more rings are attached to a single chain, then the rings are treated as substituents. For example, if you look at the first example, you have two different aromatic rings. I mean, two aromatic rings which are attached to the same single chain. That time, without assessing the number of carbon atoms, substituents. The rings will be treated as substituents, provided that there is no principal functional group attached to the ring. That is also there. In this example, if you see, there is no principal functional group attached to any of the rings. That is why both the rings will become substituents. Why? Because there is more than one ring. If there is more than one ring present, then the rings become the substituents. So this is the main chain of the parent chain 1, 2, 3. So the parent chain is of 3 carbon atoms. Propane has been used as the suffix because the parent chain has 3 carbon atoms. Phenyl rings are there, that is benzene rings are present. Since they are substituents, I have used the word phenyl. I cannot use the word benzene now. I have to use the word phenyl because when benzene is a substituent, then phenyl is the prefix for that. 1 and 3 indicate the positions of the benzene rings, that is phenyl rings. So 1, 3 diphenyl, because there are 2 rings, and that is why the word di is used. 1, 3 diphenyl propane. Second one, again you have 2 rings attached to a single chain. So 1, 2, 3, 4, 5, and 6. This is my parent. So this will be the IUPAC name. At the third position, I have bromine. At the first position, I have phenyl ring. At the fifth position, also I have a phenyl ring. So 1,5 diphenyl. Now, if I number in this way, that is, if this is 1, this is 2, and so on. If this is 1, this is 2, and so on, then 2, 4, and 6 will be the positions of the substituents. That is why I don't choose 2, 4, 6, I choose 1, 3, 5. So the lowest set of locants has been chosen. Okay. Now see, look at this note. There are some points given here. Just like I gave you the names, IUPAC names of the compounds in the table. Any doubt?
No, this will note down.
So if I write this, this can also be written as C6H5COOH. So this benzene ring containing COOH attached can also be written as C6H5COOH. Right? It is called benzoic acid. I gave you in the table. It is also called benzene carboxylic acid. Both are IUPAC names. Benzoic acid is also IUPAC name. Benzene carboxylic acid is also IUPAC name. Similarly for the others. All these are alternative IUPAC names. You should know these also. So whenever I write C6H5, it means that I have this component. This component. This is called C6H5. Now after this, I can keep attaching things here. So this will be C6H5CHO. If I make this will be C6H5CN. If I make this, then this will become C6H5CO and H2, and so on. So remember the benzene ring, whenever the benzene ring is shown, it is shown as a hexagon containing a circle inside it. If you don't draw the circle, this is not benzene. I have told you last time also. If you just draw this cyclohexane and if you forget to draw the circle, you lose marks. Because this is not benzene ring, it is just a ring of cyclohexane. So for indicating the ring, benzene ring, that is aromatic structure, you must draw a circle inside the hexagon. Else it is not benzene. So do not forget to draw the circle inside the hexagon. Or if you don't want to draw the circle, the other way to write is like this. You place 3 alternate double bonds. This is also correct. 3 alternate double bonds. But something has to be done. Either you show the 3 alternate double bonds or you show a circle inside the hexagon. You have to do any of the two. If you forget to do any of this, you lose out full marks. Full 0 you will get. Okay. So this actually was a continuation of the previous lecture. Now today's lecture will start with the
So
last part.
we can note down this part, the note thingy.
No, not required. You can just note down the examples which I wrote above for the compounds having two or more than two aromatic rings. Let these two examples. Just note down these two. So this is one example, and this second example, you can note down this. So these are when two or more, if two or more aromatic rings are attached to a single chain, then the rings are substituents. Bracket में should write that there is no principal functional group there is no principal functional group attached to any ring.
Sir, can you show that note? Yeah, this one.
Write down these examples. Okay. So we completed the nomenclature for aromatic compounds. Now the next part. So the next part is that you have to know the common names of some compounds. These are the compounds, and they on the right hand side you see their common names. Now slowly and gradually you will have to learn this. It is not that you will have to learn all now, but slowly and gradually you will have to learn. That is, once you are done with your 11th standard, then you can learn some more names because there are many names which I have given. These all are common names. These are not IUPAC names. These are common names. That means sometimes in the question they give these names, and if you don't know these names, then you will not be able to identify the compounds. If you don't know these names, you will not be able to identify the compounds. So slowly and gradually you have to learn these names. Some of these may be already familiar to you. Some of these names are very commonly used, but then not all of these will be known to you. Hence, I have given the list of common names of the compounds that you need to know for 11th as well as for 12th standards. So you can learn these slowly and gradually. These all are very much important because, as I said, in questions, sometimes they give you the common names. They will not give you the IUPAC name in the question. Sometimes they may give you the common name in the question, and they may ask you to write the IUPAC name for that compound. So if you don't know the common name, you will not be able to identify the compound. So these are the common names. Similarly, for aromatic compounds, also we have common names. Many aromatic compounds are known by their common names. Now, you will see that I have put star marks against certain aromatic compounds. If I have put star marks against certain aromatic compounds, that means I want you all to learn the common names for those aromatic compounds, maybe in the next few weeks. That is, you should learn the names of these aromatic compounds before your 12th standard starts. Hence, what I have done is I have put star marks. So, star marks indicate that for those compounds, you will have to put efforts right now. That means we'll have to start learning the common names of those compounds as soon as possible. So, when you start learning the common names of these compounds, you will see that I have put star marks. So, these star marks indicate that they are very important and those have to be learned first. Okay, now let's understand the meaning of this particular thing, the positions. The common names may use these letters O, M, and P, small o, small m, and small p. What is the meaning of each of these? Small o, small m, and small p. So ORTHO, ortho. Small m stands for meta and small p stands for para. Right? Ortho, meta, and para. Now let's understand the meaning of each of these. So small o is ortho, small m is meta, and small p is para. Now see, if I have a compound containing aromatic benzene ring, and let's say here I have something like this. Something is attached. It can be anything. Now, if at this position, let's say I have another group attached, that means I can say that the two groups are attached at adjacent carbon atoms. They are exactly one after the other. They are consecutive carbon atoms containing the two groups. Hence, I can say that both of these are attached at ortho positions. Means what? Means adjacent positions. Means consecutive positions. So I can say that the chlorine atom is attached at ortho position of benzaldehyde. Why? Because the chlorine atom is attached immediately on the next carbon atom. The carbon atom which is immediately up after the carbon atom containing CHO. So these two carbon atoms are adjacent to each other. Similarly, if I write some atom here, now also I can see that bromine is attached at ortho position of benzaldehyde, because now also the carbon atom are adjacent. So adjacent positions means ortho positions. But if I write now show, if I right now show you the attachment at some other position, let's say I have an attachment here. Now I will say that this carbon atom is containing CH2 and this carbon atom is containing bromine. These are at meta positions. META, meta. Meta means what? Meta means that not on the adjacent carbon atom, but one carbon atom after the adjacent carbon atom. That means it is at an alternate position. Similarly, if I write here, let's say I'm writing a group here. Now also I can say that NO2 is present at meta position of benzaldehyde. So meta is what? Meta is one. You leave one carbon atom and then you attach something. That is why it is called meta. What about para? Para is the diametrically opposite position. So now you can understand this. Right? Now you can understand this. If you look at this particular structure shown, here benzene ring has something called X. Let's say X can be anything. It could be any group. It could be any functional group. It could be any halogen atom. It could be anything. Something which is attached to this carbon atom has been called X. Immediately, if you look at the adjacent carbon atom, this is the ortho position, and that is why I have indicated it by writing O. So I am writing small o here. Similarly, this is another ortho position, this one. So with respect to X, I have two ortho positions, the two adjacent carbon atoms. But this is one meta position and this is the other meta position. So there are two meta positions with respect to X in this particular compound. So this is the other meta position. And I have one para position which is shown at this point. So the diametrically opposite carbon atom is called para carbon atom. So that is a para position indicated by small p. So whenever you see small o, it means ortho. Whenever you see small m, it means meta. And whenever you see small p, it means para. Now see, look at the first compound. I have two methyl groups attached at ortho positions. That is why it is called O orthoxylene. Orthoxylene. Xylene is the common name. Ortho means the two CH3 groups are attached at adjacent carbon atoms. Now, if you see the next compound, that is second one, it is metacylene. M-xylene. That means metacylene. Why metacylene? Because here, if you see one CH3 is attached, here if you see another CH3 is attached, but here nothing is attached. Right? Here nothing is attached. So at the ortho position, there is no group attached. So meta position is occupied by CH3. That is why this is called metacylene. Likewise, this will be called paraxylene because the two CH3 groups in this are diametrically opposite to each other. So OMP stand for ortho, meta, and para respectively. These are used in common names, but not in IUPAC names. You're not supposed to use ortho, meta, para for IUPAC names. You will use ortho, meta, para only and only for common names. Similarly, the fourth compound, if you see, is orthocresol. Why orthocresol? Because these two carbon atoms are adjacent to each other and they have groups attached. This will be metacresol, the fifth one. Similarly, this will be paracresol, the sixth one. And so on. So these are the common names. Learn the common names. Start learning them gradually. The ones which have been star marked are supposed to be learned first. Okay. So this is the list of common names. The list of common names is over here. Now, there is another table. See, we have already learned complex substituents and also we have learned other kinds of substituents. So if we look at this table, it has three columns. First column has around 7 substituents. The first column has 7 substituents. The second column has the names of these substituents. The third column also contains the names for these substituents. Now, we have been using these names. That is the second column. The second column contains the names which we have already learned. But the third column contains the names which we may not have learned, and that is why I've given you the third column. So that means if I ask you, for example, the third already learned as 1-methylethyl. It's a complex substituent. When I taught you complex substituents, we learned this type of thing. That is, this is 1 and this is 2. And then you say this is 1-methylethyl. Because this is ethyl, 2 means ethyl, and you have a methyl group attached here. So the IUPAC name that we have learned earlier systematically is 1-methylethyl. But also this is called propan-2-yle, and also it is called isopropyl. So these are different names for the same substituent. You should know the different names because in options, if you find isopropyl, you may get confused because you will know only this. That is why I've given you the alternative names as well. So you should know the alternative names. Similarly, the fourth one is again a complex substituent which we have learned earlier as 2-methylpropyl. That's correct. But also it is called isobutyl. So you should know the alternative names to these substituents. Similarly, the fifth one, sixth one, and seventh one. So these are some substituents who have different names. That is more than one name. This table you will have to copy. Not now, but you can copy it later. But you will have to copy this table. No. Acetyl oxy or acetoxy. Now, where do we use this? I'll give you an example to show you the requirement of this kind of substituent. Why should we know this? Now, see, If I have a compound like this, let's say I have a compound like this. Now this compound is containing a benzene ring. Also it contains COOH attached to the benzene ring, and also it contains OCOCH3 attached to the benzene ring. Right? So if I show you, if I want to write down the IUPAC name of this compound, then how will I write? The numbering will be done in this manner. Why? Because the principal functional group is carboxylic acid, COH. So this is how I will number 1, 2, 3, 4, 5, 6. At the second position, I have this as a substituent, because COOH is the principal functional group. So whatever apart from COOH is present will be treated as a substituent. So OCOCH3 is a substituent, and that is why it is called. We need to know the prefix for that. I showed you the prefix. The prefix will be acetyl oxy, and the name of this compound will be 2-acetyl oxybenzoic acid. This is the IUPAC name. Aspirin is the common name. Aspirin is the common name of this compound. Aspirin is a medicine. So what is aspirin? This is aspirin. This is aspirin. And the IUPAC name of aspirin is 2-acetyl oxybenzoic acid. So you should know that if OCOCH3 is present as a substituent, it is called acetyl oxy. Now see, one thing I'll have to show. If I write this compound, if I write this compound, if I write this compound, is there any difference between this and aspirin? Is there any difference between this compound that I've drawn here and aspirin?
So the substituent there is an ester.
Even here the substituent is an ester only, no? OCO is also an ester only.
So the location of oxygen.
Yes. So these are not same. Why these are not same? I'll show you that now. That I'll show you here. Let's say I want to draw the structure in this way. If I want to show the connections or connectivity, fine, this is COH, this is OCOCH3. This is called aspirin, which we just learned. What about this? This is not aspirin.
Sir, here it will be a ketone and then it will
No,
be
no, no. COO देखते ही आपको बोलना है कि ये एस्टर है.
a ester ही है.
COO देखते ही बोलना है. इसके लिए मैंने एग्जांपल लिया. Both contain ester as substituent. Aspirin also has ester as substituent. This also. तो ये जब होता है तो देखो लिंकेज जो है वो ऑक्सीजन के साथ है. बेंजीन रिंग ऑक्सीजन के साथ जुड़ा हुआ है. इसके लिए इस पूरी चीज को हम लोग बोलते हैं एसिटाइल ऑक्सी. लेकिन यहाँ पे ऐसा नहीं है. यहाँ पे जो है ये कार्बन के साथ लिंकेज है. एस्टर कार्बन वाला था, तो ये भी सब्स्टिट्यूएंट ही है, लेकिन इसके लिए प्रेफिक्स क्या होगा, ये मैंने ऑलरेडी पढ़ा है जब हम लोगों ने किया था एस्टर्स का। इसका क्या होगा नाम, 1 2 so on, so 2, if you remember the prefix for an ester is alkoxycarbonyl. The prefix for an ester is alkoxycarbonyl, so this will be 2-methoxycarbonyl. This will be the prefix. COOCH3 is called methoxycarbonyl. So 2-methoxycarbonyl, and then you will write benzoic acid. So this is not aspirin. These two are different things. That's why I wanted to show you this. Both contain ester group, but the linkage is different. In aspirin, the oxygen atom is directly connected. The molecular formula is the same, but the structural formula are different. So it is called methoxycarbonyl. COOCH3 is called methoxycarbonyl. Okay. Now, let's come back to the last part. Now, another thing which is pending is this. We have not done IUPAC nomenclature of anhydrides. So now we are doing that. What is anhydride? Whenever you see CO and then one oxygen atom between the two CO, it is called anhydride. Right? This is called anhydride. CO and then O and then again CO. This is called acid anhydride, or if you just call it anhydride, then also it's okay. How to do nomenclature of anhydrides? It is very simple. You will write number 1 on this carbon atom once, and then you will do the numbering on the right hand side. You will write number 1 on this carbon atom and then again do the numbering for the part attached to the left hand side. So look at the first example. Here I have done 1, 2, 3, 4. So the right hand side has been numbered as 1, 2, 3, 4. At a time, focus only on either the right hand side or on the left hand side. Don't look at both at the same time. So if I'm looking at only the part which is attached to the right hand side of oxygen, that is this oxygen, so then it will be what? 1, 2, 3, 4. The chain of 4 carbon atoms. The chain of 4 carbon atoms. How will we name this? We'll name this like this. 3-bromo, because at the third position you see a bromine attached. So 3-bromo butanoic. 3-bromo butanoic. Similarly, now you write 1 here again and do the numbering. So you will get a chain of 5 carbon atoms. At the third position you have OH. So it will be 3-hydroxy pentanoic. Pentanoic because 5 carbon atoms. So at a time we are dealing only with one portion of the compound. Either we are dealing with the part which is on the left hand side, or we are dealing with the part which is on the right hand side, but we will not look at both at the same time. So 3-bromo butanoic is the part which is on the right hand side. 3-hydroxy pentanoic is the part which is on the left hand side. And then I write anhydride at the end. So the suffix is anhydride. There is a space here after pentanoic. So after the space, I have written anhydride. So B comes before H alphabetically, and so alphabetical order has been followed. So first I wrote 3-bromo and then I wrote 3-hydroxy. So 3-bromo butanoic, 3-hydroxy pentanoic anhydride. This is the complete name of the first compound. Second one. Again, this is an anhydride because you see this oxygen atom between two CO groups. So CO and then O and then again CO. So this is again an anhydride. I have numbered both the carbon atoms containing CO as 1. So this is 1 and this carbon atom is also 1. But at a time I will look at only the I will look at only one portion. That is, either I look at the part which is on the right or I will look at the part which is on the left. If I look at the part which is on the right, it will be what? But2 enoic. That is, this portion will be the part which is on the right hand side. So but2 enoic. But2 enoic. This is the part which is on the right hand side of the oxygen atom. Now look at the part which is on the left hand side. So the part which is on the left hand side contains CHO as a substituent at the second carbon atom. So I wrote 2 formyl because formyl is the prefix for CHO because CHO is a substituent. 2 formyl, 3 phenyl. This pH, capital P, small h is called phenyl. Right? So either you call it phenyl or you write it like this. One and the same thing. So on the third carbon atom, I have this benzene ring attached, and that is why I'm calling it phenyl. So but2 enoic, then 2 formyl, 3 phenyl, propanoic. Why propanoic? See, this is a chain of 3 carbon atoms, 1, 2, and 3. So but2 enoic, 2 formyl, 3 phenyl, propanoic, and then the word anhydride. So but2 enoic, 2 formyl, 3 phenyl, propanoic, anhydride. This is the complete name of the second acid anhydride. So the first one was this. And the second one is this. Okay, let's try one anhydride now. I'll give you one anhydride. Try to write the IUPAC name for the anhydride. Let's say I have this. This is one, and this is another one. I'm giving you 2 minutes. Try to write the IUPAC names for these two. So here 1 I will write, here 2, and here 3. 1, 2, 3. So propanoic. Here I will write 1, here I will write 2. So 1, 2, ethanoic. So the name will be ethanoic. Propanoic. This will be the IUPAC name of the compound. There is no substituent attached here, so we cannot write 2-methyl or 2-ethyl of that sort. There is no substituent. This is one single part, and this is the other part. So ethanoic, propanoic, anhydride. Ethanoic, propanoic, anhydride. Here also it is 1, 2. Now, very, very important. If both are identical, then you will write this. Only once you will write this word then. Why? Because it is identical on both sides.
So no dye or something like that.
No, that is why I gave this. No dye. Kindly don't write this diethanoic anhydride. This is not correct. It is just ethanoic anhydride. So for anhydrides, if the groups present on both sides of the oxygen atom are identical, we do not use the word di. We just write the thing without using di. So this is the IUPAC name of this anhydride, ethanoic anhydride. Okay. So we did anhydrides. Then epoxides. IUPAC nomenclature of epoxides.
सर एक मिनट ऊपर देखो.
Okay. The next part, IUPAC nomenclature of epoxides. What is an epoxide? Epoxide is a type of ether, but it is a cyclic ether. That is, the oxygen forms a part of the ring. So look at the first example. The rules are same, just number the longest chain. 1, 2, 3. So 3 is the longest chain. This is the longest chain. This one. 1, 2, and 3. So this is the long. So propane will be the suffix because the longest chain is of 3 carbon atoms. 1, 2 epoxy. Now 1 and 2 indicate the positions of. So 1, 2 epoxy propane. So 1 and 2 are the positions of the carbon atoms to which the oxygen atom is directly bonded. Second example. Again, this is an epoxide. Atoms are present in the longest chain. Four carbon atoms are present in the longest chain. So butane will be the suffix. At the second position, you see this group attached, which is methyl. Right? This is methyl. So it is a substituent. So 2,3 epoxy 2-methyl butane. Third example. At the first position, I have chlorine attached. So 1 chloro. 2,3 epoxy, because between second and third carbon atoms, oxygen is there. And at the seventh one, I have this methyl which is protruding out. So this is methyl. So 1 chloro, 2,3 epoxy, 7 methyl nonane. Fourth one,
Sir, can you show the third one just for a second? Okay, sir. Done. Done, sir.
fourth one. Again, longest chain and so on. So between 1 and 4, now you have oxygen. So 1, 4 epoxy butane. This is the fifth one. I cannot do like this. 1, 2, 3, 4. This is wrong. Because if I do that, then the name will be 4-bromo 1,4 epoxybutane. This will be the name. So out of 1 and 4, 1 is lower. Definitely this will be chosen as correct and this will be wrong. So this way of numbering is wrong and this is correct.
Sir,
Okay, one important point about
please note
substituents.
that. Hello?
One important point about substituents. Keep in mind that the words iso and neo are considered by deciding alphabetical order. But the words sec and third are not considered at the time of writing alphabetical order. What does that mean? That means that when I'm writing the final name of a compound containing substituents, so if you look at this table, you have iso, sec, third, and neo. So iso and neo are considered in alphabetical order. So that I of iso will be taken for alphabetical consideration. Similarly, the N of neo will also be taken into consideration for deciding the alphabetical order. But sec and third, that is S of sec and T of third, are not taken by deciding alphabetical order. So you will ignore the presence of those when you are deciding the alphabetical order. You just look at this and this. So for sec and third are not considered by deciding the alphabetical order. Iso and neo are considered, sec and third are not considered.
So could you show the fifth example? Sir, when numbering the epoxy ones, do we have to give them also preference that they should get the lower number or something?
Yeah, same thing. Everything is same. There is no separate set of rules for epoxy compounds. Everything is exactly similar to what we have done earlier. Okay. Now let's do one question. Let's do one question. Try to solve this question now. Write down the IUPAC name of this compound. Okay. Try to write down the name of this compound. Now, what kind of compound is this?
Bicyclic.
That's the first thing. This is a bicyclo compound. Okay. Then, once we have identified the compound as a bicyclo compound, what is the next task or the next step that we look at?
Finding the
Find the
bridgehead.
Find the bridgehead carbon atoms. Find the bridgehead carbon atoms. This is another bridgehead carbon atom. Okay. Next step.
We have to start numbering from the bridgehead carbon.
Okay. Before that, identify the larger ring. Next step. Identify the larger ring and identify the smaller ring. Now, everybody can easily identify the larger ring. So I'll number them. Let's say this. I will put letters to make it more clear. Okay. So which is the larger? This is the larger ring. Any doubt anybody has so far? Okay. Which is the smaller ring? Which is the smaller ring?
EGHF.
Which is the smaller ring? Start with the bridgehead carbon atom. Like I started with A, so A is a bridgehead carbon atom. A F are bridgehead carbon atoms. Now, there are two possibilities. Either I can say that this one it is AGHF. That is one possibility. AGHF. That could be the smaller ring. Or I have A, I, J, K, and then F. A, I, J, K, F. JKF. Smaller ring. For the bicyclic,
Sir, your voice is lagging a bit.
okay, which is the smaller ring? AGHF or AIJKF?
AGHF.
No. This is the smaller ring. Why? Because AIJ. Then what is AGHF? Clear?
सर तो सबसे छोटा जो हो जाएगा वो ब्रिज हेड.
Yes.
Oh.
Bridge head नहीं. Bridge.
ब्रिज. सॉरी.
Any doubt? Okay. Larger ring has to be numbered first. So this is 1. Any doubt?
सर वहाँ पे अंडिकेन क्यों है?
सर कॉपी करना है.
हाँ करो.
सर बस डीकेन होना चाहिए था ना.
11 है ना?
अच्छा, okay.
11 so undecane. टोटल नंबर ऑफ कार्बन एटम्स 11. देखो H वाले को 11 डाला है मैंने नंबर.
हाँ सर.
This is 1. Now is this correct bicyclo? Is this clear how to number the bicyclo compounds? Any doubt? Okay, any doubt in this? Okay. Name this compound. I'm writing the compound. Name this. What is the IUPAC name of this compound? What is the principal functional group in this compound?
Ester.
Okay, ester is the principal functional group. That is correct because you see COO. Now, will my benzene be the parent structure or benzene will act as a substituent here?
It would be a substituent.
Why?
So because the main the straight chain contains the functional group.
Directly attached to the benzene ring. So benzene will act as a substituent here. Why? Because the carbon of ester, this is the carbon of ester. This carbon of ester is not directly attached to the benzene ring. So this entire thing will become a substituent. So the entire thing will become a substituent. can I say that means if ester is the principal functional group, this carbon has to be carbon 1 because there is no other principal functional group. This will be the numbering of the compound. Benzene will act as a substituent. And now what is the name? How do you name the ester? You first write alkyl. Like if you have this part will be alkyl for an ester because it's linked to oxygen atom. So alkyl part here, this part which is attached to the oxygen atom. So phenyl, right? First it will be phenyl. Propanol. So propanoate. Okay. One more example. What about this one? What is the principal functional group in this compound?
Ketone.
But that ketone carbon is connected to the benzene ring. The ketonic carbon is connected to the benzene ring, and there is no other principal functional group present. So in such a case, this has to be 1, 2, and 3. Remember this. This has to be 1. Why? Because there is no other principal functional group. So this carbon has to be 1. So this entire 1, 1 phenyl, because at the first position you have this phenyl group attached. 3 carbon atoms. So prop Any doubt? You have to write this one. Remember this. For compounds where the ketonic group is directly attached to the benzene ring, you have to write one. You cannot ignore this one. Okay. What about this one? What about this one? What is the principal functional group of this compound?
Ketone.
So it's again ketone. But is this ketonic carbon directly attached to the benzene ring?
No, sir.
So look at the difference. That's what I'm showing you. In this question, or in this example, the carbon of ketone is directly attached to the benzene ring. But in this example, the carbon of ketone is not directly attached to the benzene ring. So now you cannot write 1 here. This is wrong. Here, because it is not directly attached to the benzene ring. So now you will number like, and also you will try number and see. Which one is correct?
The second one.
Why?
Sir,
If I
because
write the second one, then the name will be 1-phenyl butan 3-one. This will be the name if I follow this way of numbering. And if I follow the first way of numbering, then it will be not tell me which is correct.
First one.
first one.
Out of A and out of B. Which is correct?
A.
A.
Why?
The lower set of
Substituent.
अरे लेकिन उसके पहले तो प्रिंसिपल फंक्शनल ग्रुप देखना पड़ेगा ना. सबसे पहले तो प्रिंसिपल फंक्शनल ग्रुप देखना पड़ता है. क्या तुम लोग जो बोल रहे हो दैट इज सेम पोजीशन. यहाँ पे प्रिंसिपल फंक्शनल ग्रुप का पोजीशन ही बदल गया ना 3 और 2. Principal functional group should get the lowest possible number. That is the first thing. Principal functional group should get the lowest possible number. तो अब कौन सा करेक्ट होगा? बी इज करेक्ट ना, 2 मिला है कीटोन को, प्रिंसिपल फंक्शनल ग्रुप है वो, और यहाँ पे 3 मिला है कीटोन को, तो ए इज रॉन्ग. हाँ, अब बताओ इसका, इस और ऐसा भी कर सकते हैं. 1 फिनाइल प्रोपान 3 फिनाइल propan 2. Now what you all said will be applicable. ये दोनों में कीटोन का पोजीशन बराबर आ रहा है, दोनों में ही ये 2 आ रहा है. तो अभी हम लोग चेक करेंगे कि सब्स्टिट्यूएंट का पोजीशन कहाँ पे है. अभी 1 और 3 को देखेंगे, तो ये करेक्ट है और ये गलत है. बिकॉज दोनों केसेस में ही कीटोन का पोजीशन सेम आ रहा है, तो तभी हम लोग फिर any doubt? Any doubt anybody has in this part? ये क्लियर हो गया? A is wrong here, B is correct. Okay. So the chapter is over. RLPAC nomenclature is over. Now see, in the next lecture we'll start with a new chapter. तो उसके पहले आप ये पढ़ के आओ, that is moles, grams and so on. जो लिखा है ये पढ़ के आओ, और ये जो SI यूनिट्स मैंने लिखे हैं ये भी आपको याद करने हैं. प्रेशर का SI यूनिट पास्कल, वॉल्यूम का SI यूनिट मीटर क्यूब, सो ऑन. तो SI यूनिट्स याद करने हैं आपको, और ये कांस्टेंट्स के वैल्यूज भी बताने चाहिए. ओके
सर जनरल ऑर्गेनिक केमिस्ट्री स्टार्ट करेंगे क्या नेक्स्ट?
नहीं, थर्मोडायनामिक्स.
ओके.
So please learn this. जो लिखा है SI यूनिट्स, यहाँ पे सारे SI यूनिट्स लर्न करके आना है. कांस्टेंट्स के वैल्यूज लर्न करो, और ये आइडियल गैस इक्वेशन, मोलर मास, ग्राम्स, मोल्स, ग्राम इक्विवेलेंट्स, ये सब रिवाइज करके. I think the next lecture is on Tuesday. Okay, thank you.
Thank you, sir.